Namaskar, welcome to my video lecture series Fundamentals of Physics. This is my 17th talk. In this particular talk, I would discuss Zeno's paradoxes and certain philosophical concepts of motion prevailing prior to the modern science. So far, we have discussed kinematics of a particle, and in that we have defined a set of kinematic quantities and discussed how mathematical methods can be used to solve problems in kinematics. We have considered a set of problems to make us familiar with the kinematics. We have used concept of particle located in a physical space, and the physical space was described using Cartesian space, Cartesian geometry. You may be knowing that Cartesian geometry came into existence or knowledge in 17th century, and it was not known to the philosophers which were knowing about the motion and have given certain ideas in the pre-Socratic period. We have also discussed the interrelated concept of time, change and motion. And you know that the time and change are interrelated. If there is a universe which has only one particle and that particle remains in the state of rest for all time, then the change would also lose meaning, the time would also lose meaning for such a physical system. And the motion, because the particle will remain in the same state, so it would also lose the meaning. So these concept of time, the concept of change and concept of motion are interrelated. As we have understood the motion in terms of change of position with respect to time, and then we have defined a set of kinematic quantities to understand the change, like instantaneous velocity, instantaneous acceleration, jerk and higher derivatives. But in doing so, we have used mathematics which have come into existence much later than the pre-Socratic or Socratic period. Mathematics of real number, some of the ideas like the idea of irrational number have a long history, and a Pythagorean philosopher, Hippasus of Metaquantum, is credited with the invention of irrational number. The concept of zero is similarly also a very old concept in philosophical literature, but its modern uses as real number which has no multiplicative inverse is a later addition. Concepts like limits, derivatives and integrals, which we have frequently used in understanding the kinematics, were given or developed in the real calculus by the inventors of the real calculus, Newton and Leibniz, in 17th century, which also involves concepts of infinitesimal, limits and continuity and infinity. In this talk is not important for those students or learners who are interested in learning physics for the entrance examination. I am not understanding evolution of concepts in physics, so they can skip it and watch my next talk, which will be made available shortly. The philosophical background of formulation of Newtonian physics as a physical theory, in my opinion, is very important just to have a deeper understanding of evolution of ideas and concepts in physics, and where these ideas and concepts in physics stand in comparison with the old philosophical ideas and what convinces us that all philosophical ideas should be discarded and the ideas and concepts in modern physics or modern science shall be accepted. It is already clear to you that the ideas or concepts in science are very important for constructing a theory, but the success or value of a theory, it depends upon its agreement in experiments. So the ideas have been discussed, which will be discussed in this particular talk from long period of time in history. In fact, the great philosopher Aristotle has written a book which has been titled The Physics, and possibly meaning Lectures on Nature. It is a named text written in ancient Greek, and in that text he has collected from a collection of surviving manuscripts known as Corpus Aristotelicum, attributed to the philosopher Aristotle. You may be knowing that a lot of scientific literature, philosophic literature and knowledge-based literature has been lost in the history due to various unwanted events, and the tyrants, the people engaging in the war have destroyed the library and the manuscripts could not survive for long. We have lost much more information of pre-Socratic period, and we know very little only about the pre-Socratic thinking and the vision only because of this fact. But Aristotle and Plato, the manuscripts which have survived, have looked into it and have contributed directly or indirectly in the development of concepts and ideas in physics in particular and science in general. And that is why I am including the discussion of philosophical ideas in this particular talk. In this talk, however, I would be only briefly examining the pre-Aristotle background of concepts of physics or metaphysics, which have an indirect bearing or relevance on Newtonian physics in particular and physics or science in general. Most important topic which I will discuss in this talk is paradoxes given by the great philosopher Zeno, which Plato and Aristotle have discussed in their work, and we will realize the importance of these paradoxes in developing concepts of physics. Ontology, as you know, is the branch of philosophy that studies concepts such as existence, being, becoming, and reality. It includes the question of how entities are grouped into basic categories and which of these entities exist on the most fundamental level. Ontology is sometimes referred to as the science of being and belongs to the major branch of philosophy known as metaphysics. Most of the idea which I will be discussing as philosophical background are part of the metaphysics. Constituent of universe. What constitutes the universe? That has been a question which has bothered the philosopher for long, and there are many different doctrines on the constituent of universe. The doctrine of monism, dualism, and pluralism in metaphysics are very, very important. And there is also a philosophical concept of nothingness, and the questions therefore may arise about what is reality, what is space, and what is time, and whether in reality is what we are seeing and observing exist, or what we see and observe is just an illusion or maya. That has also been discussed by philosophers by citing their own ideas and arguing with the competing ideas in that particular period of time. Concept of infinity by extension also appears in philosophical deliberation, and so is the concept of infinity by division. In some cases, the infinity by division or infinite division leads to the concept of atom or atomicity, assuming that the universe is made of atoms which are not divisible, indivisible atom. Remember the modern understanding of atom, because of the discovery of electron in 1897. Now we don't say that atom, which we discuss in the course of physics and chemistry, is indivisible, but it has some structure and it is a composite system. Concept of motion, change, evolution, dynamics, or laws of nature, all these things appear in different philosophies in the world, and I would be pointing out certain chosen aspects only in this particular talk. In this talk also, remember, it is not important that the modern concepts are too different than the concepts given by those philosophers in the metaphysics, as their importance doesn't lie in whether the concepts are true today or not. The importance lies in the fact that how those concepts have helped us in evolution and modern concepts, and how we could arrive at the modern ideas in the science, or how science has progressed in dealing with. So, scientists have not ignored the philosophical literature or the metaphysics in developing the new theories and new ideas, as you would realize in this series of lectures. For example, the nothingness or void or shunya as a concept may have much earlier historical origin in the philosophical literature. Modern understanding of nothingness in physics is in terms of the concept of vacuum. The modern concept of vacuum in physics is much more complex than the concept of void or shunya or nothingness in the philosophical literature. But question whether something can emerge from nothing or from nowhere was as important to philosopher as it is an important question for modern cosmologists, and they have been paying attention to it. And the philosophers of pre-Socratic period worldwide have also paid attention to such ideas. The mathematical zero and the physical notion or philosophical notion of nothingness are related but are not the same, and that should be noted. Zero may be an abstract notion which we need to introduce in the mathematics to make the mathematics consistent, and it is defined in mathematics through axioms, but at the same time one need to visualize the reality in a physical theory in terms of concepts like nothingness or void or shunya or vacuum, whatever you call. In science, we have to define the concepts in much more precise manner than we do in philosophy. That point should also be noted. This talk is also important that when you learn taking too much trivia as granted and you take everything which is proposed to you as granted, you may lose the finer understanding of the subject. Proper semantics of concepts and notions are often missed in communicating physics, and especially when the learner gets more fascinated by the beauty of mathematical methods, and also when he develops a love for making conjecture and making a superficial understanding, then in-depth understanding is missed in the process of learning. I would try my level best to emphasize the in-depth understanding and tell you the important points which are essential for in-depth understanding in my video lecture series. I have realized this because while teaching physics for over 4 decades, I have realized and noted that the semantic failure and habit of not asking questions, these are two major hurdles in proper learning of scientific ideas or theoretical physics. In case of scientific experiments also, similar problem arise because the performer of experiment may fall in love with the experiment so much that may not realize the limitation and accuracy of the experiment, the specificity of the experiment, and may conclude or wrongly and may generalize the results of the experiment to the domain in which the result of the experiment cannot be extended. So it is very important that while learning science or physics, one should not get carried away by emotions. One should not make conjectures and superficial understanding. One should not have a fear of asking questions, and one should try to make an effort to have a proper understanding of the semantics of all the concepts and notions involved, and should also keep in mind the limitations of experiment. So this talk is especially designed for these aspects. In this talk also, we will point out that there have been several ideas like concept of zero, values of numbers, small and large values of time or space or length, ordered space, finitude and infinited, atom and infinitesimal have evolved over a great period of time. And these ideas and numbers which may have figured in earlier in my presentation of kinematics, but historically the ideas were known quite earlier than the systematics of kinematics which we have discussed was developed. It is not important also that who should be credited for the invention of, for example, zero. As the zero initially conceived and now used in modern mathematics and physics or science may have different meaning and different semantics. So due care must be taken in understanding. So there are different views about zero, and in a philosophical literature when zero appears, it may have much different meaning than the meaning which we now use in our analysis. But it is important to understand the views of philosopher so that we can make a finer understanding of the concept of zero also, and we could realize the importance of the zero in physics and why we had to modify the philosophical concept to suit our calculations in theories in physics or science. That also would become clear when you take interest in the deeper meaning of the terms which otherwise appears very easy and people take as granted. So if you call that what is zero, maybe there may be a layman who can say that I understand what is zero, but to understand zero in the manner in which we use it in mathematics, used in physics, is not such a simple thing. The Mayan numerals, for example, which go back to 37 before Common Era, used base 20 numbers and 3 basic symbols including 0, which was meant to be a placeholder. But the Mayan system of numbers lacked economy of notation, requiring more than one symbol and position to represent even the numbers between 6 to 19. And as a result, 0 was not a perfect positional element in the Mayan numerals. It is a perfect positional element in our modern understanding of what we call decimal system. And that is why George Zefra called the Mayan numbers as a field system. But that is not to undermine the importance of Mayan numerals in historically significance of the Mayan numerals and the way our understanding of the number has improved. Similarly, It is also believed that Arab merchants brought the zero they found in India to the West. After many adventures and much opposition, the symbol we use was accepted and the concept flourished, as zero took on much more than a positional meaning. So the modern meaning of the zero is different than the zero which was communicated by the Arab merchant. They took it from India and to the West. But it is important that this thing has played a vital role, and now the concept of zero is so much important in developing consistent mathematics that it plays a vital role in mathematizing the word or the ideas or concepts in physics and science. Similarly, several very small units of time were introduced in Jain cosmology. But the modern concept of infinitesimal was difficult for them to consider, or there was no such necessity, and therefore the concept was not conceived in that particular period of time. But this is an important fact, that they could realize the importance of very small units of time, and though they could not arrive at the concept of infinitesimal as it appears for the time or any variable in the modern understanding of physics or science. The important fact is that, for example, the debate of atomicity, it has also been going on for long in philosophical discourses. Whether you attribute it to the Jain philosopher or the later Saint Kanad or some Greek philosopher, that historical debate may go on, but it is not important. Important point is what was their idea and what is the chain of evolution of the concept of atom which Jain philosophers thought, which Kanad thought, or Greek philosopher thought, and the atom which we see or use as a concept in the physics or science. So the evolution of the word atom is very, very important from the ancient philosophical view to the modern view in science, and this lecture particularly would highlight this. In this light also, this talk is a little exercise only and cannot cover, because the topics are so vast, everything which should have been covered or which may be covered or which should be covered. So I would limit myself. I begin with the ideas which were given in the Jain philosophy. You may be knowing that the Jain philosophy has a very old history, and one of the Tirthankar of Jain, Vardhaman Mahavir, is supposed to be alive in the period 599 to 527 before Common Era. They also had the view about cosmology and the constituent of the universe. They divided the constituent of the universe into two classes major, the class of Jiva and class of Ajiva. Jiva and Ajiva. We also use these terms in modern time also in biology. But the difference is that the view of Jain philosopher was not biology as an emergent phenomenon. Biology is an emergent phenomenon as in modern view of origin of life, and it can be understood in terms of the fundamental sciences like chemistry and physics. But the Jain philosopher or Jain philosophy is an atheistic philosophy, and they thought there is no need of involving a creator or something divine, and so in the Jain cosmology there is no role of creator or divine in the description of the cosmology. According to Jains, the universe is made of 6 simple and eternal substances called dravya, which are broadly categorized one under the main category called Jiva and the 5 Ajiva. Jiva exists as a reality having a separate existence from the body that houses it, and it is characterized by characteristics like chetana, consciousness, and upyog, the knowledge and perception. Thou, the soul experiences both birth and death, but as per Jain, it is neither really destroyed nor created. That was the concept of soul or atma or jiva in the Jain philosophy, introduced by a Jain philosopher, maybe Jain philosopher prior to the Tirthankar Vardhaman Mahavir. So it has been a very old idea of classifying that what are constituents of universe and classifying the constituent of universe into categories. They had done it for the constituent of universe. Scientific debate, however, may reveal that the present views of consciousness is beyond the comprehension of the Jain philosopher. So scientific debate about consciousness is also beyond doubt the present level of the series, and we cannot discuss it at this level unless maybe towards end of the series I would take up the modern concepts of consciousness which are emerging and are being debated by the scientists. And at that time also we may realize that the old philosophical views, how close they are to modern scientific views, or whether they are very far from modern scientific views. The Ajiva or Ajiva have been classified into 5 categories: Udgala, Dharma, Adharma, Akash and Kal. Udgal or matter can have different forms like solid, liquid, gaseous, energy, fine karmic materials and extra fine matter, that is the ultimate particle. That is a view of matter in the Jain philosophy. Parmanu or ultimate particle is the basic building block of all matter in their philosophy. The Parmanu and Pudgala, like the Jiva or soul, are permanent and indestructible. Matter combines and changes its modes, but its basic quantities remain same. Basic qualities, remains the same. According to Jainism, it can neither be created nor be destroyed. For a long period of time in the history of physics also, we used to believe that the matter cannot be created nor it can be destroyed prior to the proposition of energy mass equivalence relation by the Albert Einstein, and now we know that matter can be converted into energy and the vice versa. The Jain philosophy also talk about the principle of motion and the principle of rest. The principle of motion is called dharmasthya or dharma dravya, and the principle of rest is called adharmasthya or adharma dravya. So the dravya, there are 2 kinds, dharma dravya and adharma dravya. The dharma dravya means is related to the principle of motion, and adharma dravya is related to the principle of rest. So this particular view of dharma is maybe different than the common view of dharma which you find in different Indian philosophies. Dharmasthya and adharmasthya are distinctly peculiar therefore to Jain system of thought, depicting the principle of motion and rest, and the principle of motion and rest are of our interest. But what they think, they are said to pervade the entire universe as per Jain, the dharmasthya and adharmasthya. Dharmasthya and adharmasthya are by itself not motion or rest, but they mediate motion and rest in other bodies. Without dharmasthya, motion is not possible and similarly without adharmastakya, the rest is not possible in the universe. So the Jain philosophy in that manner discusses the principle of motion in quite different manner than the principle of rest and consider them as mutually different concept. Another concept or component of the Ajiva is the Akash or the space. Space is a substance that accommodates the living souls, the matter, the principle of motion, the principle of rest and time. It is all pervading, infinite in their view and made of infinite space points. So the concept of space was conceived by the Jain philosophers in that period of time. They also conceived the concept of time or kal. Kal is an eternal substance according to Jainism, and all activities will change or modify can be achieved only through the progress of kal or the time. But there is a difference and a further classification or sub-classification of the kal in the philosophy, that conventional time or called vyavahar kal is perceived by the senses through the transformations and modification of substances. So what we can perceive or know is the vyavahar kal. But the real time or nishchay kal, however, is the cause of imperceptible, something which cannot be perceived, and it causes the minute changes called vartana that go on incessantly in all substances. So the changes which happen are attributed to the vartana. Now we come to another atheistic school of philosophy. The Charvakas school of philosophy predated the Aztec schools as well as being a philosophical predecessor to subsequent or contemporaneous philosophies such as Adhyana, Ajivika, Jainism and Buddhism in the classical period of 11 different schools of Indian philosophy. In that period, the 11 different schools of Indian philosophies were having constant debate and argument and discussions. The Charvak doctrines are found in texts during the 6th century before Common Era, the information which is available historically. They held perception and direct experiments only to be the valid and reliable source of knowledge. One does not and cannot perceive the atman, and one cannot establish its existence with the help of inference, because inference is not a valid source of knowledge as per Charvakas. The Charvakas states that consciousness is not due to the atman, it is an emergent phenomenon. So the concept of emergent phenomenon and the consciousness as an emergent phenomenon was introduced long back by Charvakas in their philosophy. Consciousness, therefore, as it appears in Charvakas philosophy, is different than as it appears in the competing philosophies. Consciousness, thus, as an emergent quality of the physical parts coming together in specific proportions. They argue, for example, that when yeast is blended with certain juices, it turns into wine. The property of being wine is a new quality which yeast and juices obtain when blended. And therefore, according to Charvak metaphysics, life is also only a new configuration of matter. Nothing but matter is real. They believed that consciousness in its experiencing function is the mind. Mind knows the external world through the senses. Charvakas deny the reality of the constituent of universe called ether, which was proposed by other philosophies, competing philosophies. They believed only in logically proving explanation of nature very close to the practices of science. As per Charvak, there is no God, no samsara or rebirth, no karma, no duty, no fruits of merit, and no sin. They believed God, whose existence cannot be perceived, fares no better than the soul or atman. The material elements produce the world, and the supposition of a creator is unnecessary. And today also in scientific understanding, we find that the life and the dynamics of the universe comes or appears as an emergent phenomenon, and the basic constituents of nature and the interaction between these basic constituents we would discuss in great detail towards the end of series. Charvak metaphysics are of the faith that there is no external cause. So there they differ from the scientific approach. There is no external cause for the four elements coming together and obtaining the qualities of life and consciousness. It is their inherent quality to come together and to have those qualities in their opinion. However, one cannot generalize on this process and establish a law that whenever these four elements come together in certain ratio, life and consciousness will emerge. The elements may alter their nature at any time. Contrary to the modern belief, the laws of nature are such that they are divine, they cannot be changed. But one cannot therefore say the nature comprises some internal laws as per Charvakas. Every event is a probability. And this is an important aspect of their thinking, that they could think of that every event is a probability, which is very close to the modern view of quantum mechanics. Every event is a probability, and if it develops into something, then it develops according to its own peculiar nature. One may conclude that according to the Charvak metaphysics, the existence of everything is just a chance and there are no laws of nature, but every object possesses its own nature. There are many other philosophies and competing philosophy to those which I have discussed so far. Buddhists also believed in atomism, and Buddhist atomism is very close to Aristotelian style atomic theory. In this form of atomism, the constituent of the universe are four kinds of atoms, or corresponding to the four standard elements which they believed are earth, water, fire and wind. Each of these elements has a specific property such as solidity or motion, and also performs a specific function in mixtures as per the Buddhist and Aristotelian style view, such as providing the support or causing the growth. This was a very common pre-Buddhist Indian idea shared by the Greek, that the universe is made of limited and unchanging substances, like in Jain philosophy or the other philosophies which I have discussed so far, that combine and recombine to produce apparent changes in the empirical realm. The Indians and Greeks numerate the exact same four elements, frequently augmented by the fifth element of ether, the Akash in Sanskrit and the ether in Greek. In parallel fashion, the Greek cosmologist Thales believed that water is the ultimate principal constituent of the nature or originative substance of the nature. Anaximenes believed that air is the ultimate or originative substance of the nature. So atomicity is about the constitution of universe or matter. Atomic theories mean existence of small indivisible units called atom, but in contrast to what we use in physics in modern time, after the discovery of the electron, when we have found that the atoms before 1897 were supposed to be indivisible, but now we use the same term but with a different meaning, and the atom in atomic and modern physics is a divisible or a composite system. It's very important, therefore, to pay attention to what is reality, ever changing, or whether reality is ever changing or it is static, whether it is becoming something or evolving into something, or it is just eternal, it exists as such, or monism in reality is observed, or the motion is just mind. All these aspects were paid attention by the great philosopher of pre-Socratic time, and now I will take those aspects in discussion. Heraclitus of Ephesus, he was active in the period 535 BC to 475 BC, born in 535 BC before Common Era and died maybe in 475 before Common Era. The figures may have different figures you may find in the literature because it is very difficult sometimes to establish the correct historical dates in such cases. He believed, a great philosopher, Heraclitus of Ephesus, believed that the change is ever present, and he thought that a philosophy which we call the philosophy of flux or philosophy of becoming as the characteristic feature of the world, and he was therefore a non-believer of the static concept, an idea he expressed in the famous saying, "No man ever steps in the same river twice," which means the next time when you step in a river, the river has changed because the river is flowing. But his belief was that this is not only true for the river, it is true for the entire universe. And so he proposed the philosophical ideas, paying emphasis on the concept of flux or the concept of becoming, or you can say ever-present change. He expressed his ideas of flux by saying that sun is new every day, rather than thinking that the same sun will rise tomorrow. So if you think that the same sun is rising, then it's not the same sun. So it has a great philosophical consequences also. All things, in his opinion, come into being by conflict of opposites and the sum of things which we call the whole. So either there is a conflict of opposite or there is addition of similar things or the sum of things, but the common thing is that they flow like a stream. All things are an interchange for fire and fire for all things, he said. But maybe by the fire he was meaning the energy. So all things are forms of energy as we find in a particular view of science and physics, and the energy can change its form and the matter can also become energy. But the Heraclitus was also pointing out that all things are an interchange for fire and fire for all things, just like goods for gold and gold for goods in the barter system. The competing philosopher Parmenides of Eleatis was of much different view, and he has a contrasted view, and he believed in being rather than becoming. That is, he was not a believer in the ever-present change, but his idea was that the nature of the universe is static and nothing is changing. He argued that everyday perception of reality of the physical world by us is mistaken, and that the reality of the world is that one being an unchanging, ungenerated, indestructible whole. Remember again, he is of the view that it is ungenerated, unchanging, and indestructible whole, the reality. So the phenomenon of movement and change are simply appearance of the changeless, eternal reality. Otherwise, no change is happening, and change is just an illusion. He believed, or his beliefs can be expressed by his statement, whatever is, and what is not, cannot be. That also means that whatever exists, exists, and something which cannot exist cannot be also. Scholars have generally believed that either Parmenides was responding to Heraclitus or Heraclitus was responding to Parmenides in their discourse or discussions or philosophical sayings. Parmenides of Elea also argued that movement was impossible because it requires moving into the void, and the void, in his opinion, cannot exist because nothing cannot exist, and therefore the only thing which can exist is the never changing thing, and that is the Parmenidean one, in as it is referred in today's literature, or especially in the book Parmenidean by the great philosopher Plato. Parmenides claimed that there is no truth in the opinion of the mortals. Genesis and destruction, as Parmenides emphasizes, is a false opinion because to be means to be completely, once and for all. What exists can in no way not exist as per Parmenides' philosophy. According to Diogenes Laertius, Parmenides composed only a single work, and most of that work was lost, however, and this was a metaphysical and cosmological poem in the traditional epic medium of hexameter verse. Both Heraclitus and Parmenides had a great influence on Plato, who went on to influence the entire school of Western philosophy. But most profound was the Zeno, the associate of Parmenides. Zeno of Elea was born around 419 before Common Era, and he lived for 65 years. He was a pre-Socratic Greek philosopher from Magna Graecia and a member of the Eleatist school founded by Parmenides. The dynamic occasion which Plato has described in the dialogue Parmenides is a visit of the Parmenides and the Zeno to the Athens, and they attended the great festival, or the festival of the great Panathenaea, and Plato describes Parmenides was about 65 years old at that time, Zeno was nearly 40, and he says Socrates conversed with them and he was quite young then, which probably means that Socrates was about 20 years. So Zeno and Parmenides were older than the Socrates and are considered pre-Socratic philosophers. Aristotle had a praise for him, and he called him the inventor of the dialectic. He is best known for the paradoxes which have been described in detail, and some commentary has been given by Plato and Aristotle in their own work. The work is so profound that the great philosopher of modern time, the Bertrand Russell, described the Zeno as immeasurably subtle and profound philosopher, maybe of all time. Although we don't know from Zeno himself whether he accepted his own paradoxical arguments or exactly what point he was making with them. A lot of information has been lost in the time and the manuscripts are not available. The original contributions of Zeno have not been recorded, but he has given many paradoxes. According to Plato, the paradoxes were designed to provide detailed supporting arguments for the thinking of Parmenides by demonstrating that our common sense confidence in the reality of motion, change and ontological plurality is wrong. That is, that there are just many things. It is meant by ontological plurality means that is that there are just many things, and he wanted to point out that these concepts involve absurdities. Since Zeno's argument in fact tend to problematize the application of quantitative conception or qualitative conception also to physical bodies and to spatial expenses as ordinarily conceived, the paradoxes may have originated in reflection upon Pythagorean effort to apply the mathematical notion to the natural world. And Zeno's 40 paradoxes have been debated in the literature. Much more than that he may have contributed in his own time. Zeno's paradoxes had a lasting impact not only on the Greek philosophers subsequent but also in the development of the present day physics or the evolution of the scientific ideas. And that is why now I will discuss the paradoxes of Zeno in this lecture. Before Zeno, however, Greek thinkers favored presenting their philosophical views by writing poetry. Zeno began the grand shift away from the poetry toward a prose that contained explicit premises and conclusion, and he employed the method of indirect proof, which is better known as paradoxes. In this method, first you temporarily assume some thesis that you wish to oppose, and then you attempt to deduce an absurd conclusion or a contradiction, thereby undermining the temporary assumption. This method of indirect proof is also known as reductio ad absurdum, probably originated with Greek mathematician, but Zeno used it more systematically and self-consciously. In this talk, we will discuss 5 paradoxes given by Zeno: the dichotomy, the Achilles, the arrow, the stadium, and the plurality one by one. So I begin with the dichotomy. The thesis is that things can move. So that is what Zeno wanted to oppose, that things cannot move. And the argument given by the Zeno is, it is the one about a thing is not moving because what is traveling must arrive at the halfway point before the end. So if you wish to travel from A to B, you have to first arrive at a middle point M. So midway you have to arrive. If you wish to travel from here to here, you have to arrive at this middle point M. Now you can say the same argument. If you have traveled to this point from this point, you have to arrive at the another middle point M dash. And similarly, if you have to move from A to M dash, you have to arrive at middle point M double dash, and so on. You can continue, and that process we call ad infinitum. We can continue in this manner that to reach from A to B, one has to reach a middle point M in between. So the one about the thing is not moving because what is traveling must arrive at the halfway midpoints before the end. But when you apply it ad infinitum, there is a contradiction. And he says that if anything moves from one place to another, then it performs infinite many tasks. And nothing in his view can perform infinite many tasks, as it would require infinite time as well as infinite energy to perform those tasks, and therefore he concludes that nothing moves. So he said that if you wish to move from a point A to point B, you have to carry out infinitely many tasks in this manner which we have shown earlier, that the A to B middle point M, A to M middle point M dash, A to M dash middle point M double dash, A to M double dash middle point M, and so on ad infinitum. So it requires infinite many. The motion from A when to B would involve infinite many tasks, and he argues that infinite many tasks cannot be performed by a living being. And so he said that nothing can perform infinitely many tasks, as it would require infinite time to complete those tasks, even if some finite non-zero time is required for completing time. In very small amount of time is required for completing one task, but since infinite tasks are involved, so that would require infinite time as well as infinite energy. Now you may think how we have resolved it. In Cartesian space and time, we have used real number, and they have real number like continuity in each dimension, and not like what the Zeno is describing in his supposition or proposition. Resolution, therefore, of this paradox comes from the calculus, the new way of doing calculation. And this calculus, as you know, we could develop, or Newton and Leibniz could develop in 17th century, much later than the Zeno. And now we understand the distance traveled of displacement in terms of what I have so far discussed in kinematics, and you have a better understanding in terms of the kinematic quantities involving their definition, involving derivatives, and how we can obtain the displacement by integration of instantaneous velocity we have learned. So this particular paradox would help us in realizing the importance of the mathematics which we have used in our discussion so far in the kinematics. The second paradox is the paradoxes of motion, is the Achilles. In this paradox, the thesis is that faster can never catch slower moving ahead. A slower person is moving ahead, then the fast person who is behind him would not be able to catch him. We know that if a slower person is moving, then the fast person who may be behind certain distance can catch ultimately the slower person, as we find. But the argument of Zeno has been to make this thesis and then to prove that this is not possible by logical argument. An argument is this: he says that the slow will never be caught in running by the fastest, because for the pursuer must first get to where the pursued started from, so that it is necessary that the slower should always be some distance ahead of the pursuer. Like this. So suppose this slower is here and the pursuer is here. Then when the pursuer comes to this point, in that particular period of time, the Zeno argues the slower has also moved ahead. So now again the problem becomes similar, that the slower is here and the pursuer is here. And then he says that when the pursuer reaches to this position, then again the slower has moved ahead. And the ad infinitum, he says that slower should always be ahead of the pursuer, or therefore the fastest can never catch the slower movement. So argument can be written like this also: for every instant or I, if Achilles is at ti, the pursuer, and tortoise, the slower, is ahead at some instant ti plus 1 at some point, then for every point p on the race course, if Achilles is at p, the tortoise is at some point p dash, such that p dash is further from p, as explained in this diagram, and ad infinitum, Achilles is always behind the tortoise to cover the gap of last space. Now we know that we have resolved this. Time taken in covering a distance will not be computed in the manner in which the Jiva or all philosopher have thought, but it would be computed through techniques involving integral calculus or integral calculations. Thus, both over some period will cover finite distance, but distance traversed by the Achilles in the same period will be increasingly more than that by tortoise, and finally therefore at some instant of time the Achilles will be able to catch the tortoise. So the paradox we have resolved by the use of calculus. The third paradox is the paradox of the arrow. Thesis is the arrow can move, and the argument against that the arrow cannot move is that something at rest. What should be called at rest? So Zeno proposes that something at rest occupies the volume in space equal to its own volume. So he says that at every instant during its flight, a moving arrow is at some point in its trajectory and is also occupying a portion of space equal to its volume or itself. Hence, it does not move during that instant. But since this holds for every instant throughout the flight, and therefore the arrow never moves. And this particular paradox we have been able to resolve by introducing the quantities by using the differential calculus and the concept of derivatives. And now we understand that every instant the particle has not only the position vector, it also has an instantaneous velocity vector, an instantaneous acceleration vector, instantaneous jerk vector, and other higher derivatives in the same manner is associated with that particular instant. So when you make use of the calculus, the differential calculus, this problem pointed out by the Zeno get resolved. We have already made use of it, and so you could not realize that there can be some objection, but Zeno has pointed out these paradoxes long earlier, and in the manner we have developed the kinematics so far, we have taken care of Zeno's paradoxes of motion. The fourth paradox is the stadium. If an object is moving 1 unit distance in 1 unit of time, it will do so independent of observer. Argument is that consider bodies of equal length aligned along 3 parallel rows within a stadium. One track containing A bodies, another track containing B bodies, and another third track containing C bodies. Each body is at the same distance from its neighbor along its track. The bodies which are A bodies are stationary, the B's are moving to the right and the C's are moving towards the left, but B's and C's are moving with the same speed. So it is shown here. Here are 2 snapshots at a particular point before taking the snapshot. The 3 A's, 3 B's and 3 C's. These ABC are aligned, and now you know that this A is on the particular to this particular C, it is on the left, and this A is on the right, and similarly you can describe relatively. So the situation, a snapshot is shown at a particular instant. Now the B is moving in this direction and C is moving in one direction. So after 1 unit of time or 1 instant of time, what you will find? You will find a configuration like this. And the configuration like this, very easy to see from the figure, that when this row is moving with 1 unit at a time, so this B will come just below this A, and so this is the picture. And if this C is moving in this direction, then this C will come just below this particular leftmost A. So this is the picture after 1 instant of time. Now the Zeno points out the paradoxical situation here. He says that in the time between the before snapshot and after snapshot, the leftmost C passes 2 B's but only 1 A. And in his opinion, contradicting the very controversial assumption that she should take longer to pass 2 B's because it is traveling with some speed 1 unit of distance per unit of time. So in the Zeno's argument, it should have crossed only 1 B, but it has crossed 2 B's and only 1 A. So that is a contradictory situation. The usual way out of this paradox is to reject the controversial assumption, and we have dealt the similar problem with the notion and concept of the relative motion, which I have discussed, and with the use of quantities like instantaneous velocities. So we have been able to manage our fine resolution of the problem or paradox of the stadium. There are other paradoxes which corresponds to the infinity by division, and these paradoxes are called also the paradoxes of plurality. There are two paradoxes only I will cite here. One of the better known plurality paradoxes addressing infinite divisions. And suppose you have 1 meter road, then you can divide it into two pieces. Now keep one half with you and divide it again into two pieces, keep one half with you and divide it in again two pieces. In this manner, ad infinitum, what will happen? So if something is divisible, Zeno says that it is infinitely divisible. We can keep on dividing. Okay? That is a presupposition here. And now if each part has zero size, then the total also has zero size. So after infinite division, you are having something which you may call particle or anything, and then if this particle or anything is having zero size, then if you add 0 infinite times, then you also get 0. So if each part after infinite times is having 0 length, then the length will be total equal to the 0. But if on the other hand you say no, each part has some finite size, then he says that the total will be infinite, because if finite numbers are added infinite times, it would give you the infinite, however small the number may be. So even if you add 0.1 plus 0.1 plus 0.1 infinite times, you will get infinity. Or 0.001 plus 0.001 infinite times, you will get infinity. So that Zeno is pointing out that there is some flow in understanding, because if something is divisible and infinitely divisible, then the part to which we have after ad infinitum division would be, if is having 0 size, then the size of the object which has been divided to achieve the particle was 0 either or was infinity. So he says if something divisible is either infinite or has no size at all. The something finite is not divisible. So that is the beauty of Zeno's argument. He gives argument in such a manner to believe something which you have observed empirically to be true. And so he has been emphasizing that what you are seeing, that something finite which is divisible, is an illusion. In fact, like the Parmenides has said, the reality is not divisible, is eternal, and it is being, and it remains as such. And if it is appearing like divisible to us, it is something like illusion or maya. The resolution here comes from integral calculus, and there we have defined metric, and we now know that the integration of dx from x1 to x2 is finite, x2 minus x1, and dx is the infinitesimal. So with the introduction of the concept of infinitesimal in calculus and defining the derivative and integral calculus antiderivative, we have been able to resolve this particular paradox of the plurality. There is another way of expressing the paradox of plurality, that the total number of things is either both finite and infinite in proposition of the genome. Because if it is finite, it should be finite, the total number of things, because if there are many things, then there must be as many as there are, neither more and nor less, and in that case their number is limited and hence finite. But then he argues that on the other hand, if there are many things, they must be infinite in number, because between any two there must always be others, and between these others, so on, there would be others, and so on, continue ad infinitum, and so you find that there should be infinite. This paradox is actually pointing out, now we understand, to the special point of the real numbers. And the real number mathematics, you know that between two real numbers there are infinite real numbers. So the idea the real number which now we have, in fact, has been pointed out in this paradox indirectly, not directly. And so we could resolve it by using the concept of real numbers and the concept of real number or point-like continuity which we observe in real number, and by developing real analysis. So all the five paradoxes discussed so far have been paid attention to by us in development of mathematics required for description of the kinematics. Then Bandete has given another modern version of dichotomy, and that is also interesting, so I wish to include in my presentation. And it brings about the conceptual difficulties inherent in infinite tasks in the paradox. The paradox is the paradox of the gods. Suppose Achilles want to run the length of a racetrack, but there are an infinite number of gods who have following intention. The first god intends to paralyze Achilles if he reaches the halfway mark. The second god intends to paralyze Achilles if he reaches the quarter mark or 1/4 mark. The third god similarly 1/8 mark. The fourth god 1/16th mark, and so on ad infinitum. So as in the reverse dichotomy, Achilles cannot even start running. To do so would violate the intention of an infinite number of gods. However, it is not clear why he could not start running, for until he does so, no god has actually paralyzed the Achilles. So very interesting paradox. Suppose the next paradox I wish to take up, the paradox of the spaceship. Suppose that a spaceship travels in a straight line for half a minute and then doubles its speed. Then in a quarter minute, let us again doubles its speed, and then 1/8 minute again double its speed ad infinitum. So where it will be in the end, because after every such fraction, half time fraction, the doubling of the speed is occurring, so it must end infinitely far away. But does that make sense? That in finite time of 1 minute, it achieves infinite distance. The resolution, it is difficult to accelerate in this manner as per calculus, and we know the quantities will get very high, acceleration would become very high. But if possible, definitely in our analysis, it would also travel to infinite. However, now we have theories like special theory of relativity, where there is a limit on the speed which an object can have, and that limit is the speed of light. So there should be a limit to the speed that has been pointed out indirectly in this paradox of the spaceships, and that's why the paradoxes are important. Now another paradox, the flying bird paradox. Suppose two people, Ram and Shyam, are walking towards one another, and a bird is flying back and forth between them. When it reaches Ram, it turns around and flies until it reaches Shyam, but when it reaches Shyam, again turns around until it reaches Ram, and so on and so forth. Assume that the bird takes no time to turn around. Which direction is the bird facing when Ram and Shyam meet? So that's a very surprising question. You can't answer the question because it has been put in such a paradoxical manner. However, resolution of this problem we understand. Due to limitation in measurement and however small but finite size of bird, it is difficult to discern unless details are worked out theoretically, considering with best accuracy of measurement. But it is not resolved in a true sense, as laws of nature may forbid such a motion at very, very small length. So it can be resolved in that way. The concept of infinity also appears sometimes absurd, because math says that the infinite set, math defines an infinite set in an axiom. Suppose there exists at least one set W with the properties that the null set is the member of the W, and the criteria P that if X belongs to W, then X union the set X also belongs to W. This means that since now the null is belonging to the W, the null is the member of W, the null with the null set, this particular is also member, and so on. So what the have, it would go on continue involving infinite null sets. So what the heck is this? A big set of nothing. It is a definition of counting in disguise. There may be other problems, like you know that you can resolve the problems indicated by the Zeno, that by knowing the fact that the converging series, and which we have learned. So you know that half plus 1 by 4 plus 1 by 8, if you complete the journey in this manner, first half and then 1 by 4 and then 1 by 8 plus 1 by 16, and if the series goes up to infinity, it can be very easily proved that this is equals to 1. But there are interesting arrangement in the proofs, like you can start with the 0 and write 0 as 0 plus 0 plus 0 plus, and then you find that 0 is, this 0 you can write as 1 plus minus 1, this 0 also as 1 plus minus 1, and all the zeros like in this way. Then what you can do, you can regroup, that keep this one different aside, and now combine this minus 1 with this one, this minus 1 with this plus 1, and this minus 1 with the next plus 1, and so on infinite times. And so what you have? You have 1 plus 0 plus 0 plus 0 plus so on. So what we have proven in this method, so we have landed up in a problem and we have shown that 0 is equal to 1. So infinite series are a matter of limits, and whenever things like such happens, we have to go back in mathematics and fix them, and we have developed the analysis and the real analysis to resolve all such problems. And therefore the concepts which are there and which have been better defined later on, though the calculus was given by the Newton and Leibniz, I would prefer that you go through the Cauchy's definition of the concepts. The Cauchy's definition of a limit is when the values successively attributed to the same variable approach indefinitely a fixed value, eventually differing from it as little as one could wish. That fixed value is called the limit of all the others. This definition of infinitesimal is also given by Cauchy. Cauchy's definition of an infinitesimal is that when the successive absolute values of a variable decrease indefinitely in such a way as to become less than any given quantity, that variable becomes what is called an infinitesimal. Such a variable has 0 for its limit. Then the Cauchy has defined the continuity also, that let fx be a function of variable x, and let us suppose that for every value of x between two given limits, x1 and x2 maybe, this function always has a unique and finite value. If beginning from one value of x lying between these limits be assigned to the variable x an infinitely small increment small a, the function itself increases by the difference f of x plus a minus f of x, and which depends simultaneously on the new variable a and on the value of the function at x, or the value of the x. Given this, the function fx will be a continuous function of this variable within the two limits assigned to the variable x if for every value of x between this limit the absolute value of the difference decreases indefinitely with that of a. In other words, the function fx will remain continuous with respect to x between the given limits if and only if between these limits an infinitely small increment of the variable always produce an infinitely small increment of the function itself. So Cauchy has also defined the derivative, which I have discussed earlier. Now the Cauchy's definition of derivative is that when a function y is a function of x remains continuous between two given limits of the variable x, and when one assigned to such a variable a value enclosed between the two limits at issue, then an infinitely small increment assigned to the variable produces an infinitely small increment in the function itself, as discussed in the continuity. And consequently, if one puts delta x equals to I, the two terms of the ratio of differences delta y by delta x, which is given by function's value at x plus I minus function's value at x divided by I, will be infinitely small quantities. But though both the delta y and delta x are infinitely small quantities, these two terms will approach the limit 0 indefinitely, and simultaneously the ratio itself. So the delta y tends to 0 and delta x may be tending to 0, but the ratio itself can converge towards another limit. It can be positive or negative, and this limit, when exists, we say that the function has derivative or has a definite value for each particular value of x. The form of the new function which it defines is given by the limit delta x tends to 0, delta y by delta x, already defined in my course as the first derivative of y with respect to x. And in literature, you can denote the first derivative by either using y prime or f prime of x or dy by dx. We would be using dy by dx for explicit clarity. Now the integration as a summation is also helpful because it resolves most of the paradoxes which have been pointed out here. And I have earlier said that the integration gives us the area. Suppose we integrate this function f of x, and from the limit x equals to a to x equals to b, I have said that this is the area which is equivalent to integration of f of x dx from x equals to a to the x equals to b. And you can understand it in explicit manner. You can divide this particular area into fine vertical strips, very small, and so that the width of the strip is infinite small. And so consider one such strip which is having a very small delta x width, and the height at this particular point is say y or fx. So the area of this particular strip can be considered as a rectangular strip, and that area would be given by delta a equals to fx times d delta x. And then we can add all such areas and we can obtain the total area. But if you obtain the total area under the limit delta x tends to 0, by making this strip smaller and smaller, the delta x smaller and smaller tending to 0, then this reduces to the definition of integration or definite integration. So we find that the distances are obtained by integral calculus, and integral calculus is new way of doing calculation when continuous variables or continuous functions are involved. And the old-fashioned computation of discrete numbers which people were knowing for long is not applicable and may lead to paradoxical situations like Zeno have pointed out. So let me conclude that we have already used all these concepts in tackling with the Zeno's paradox without mentioning in my discussion on kinematics so far, and we will continue to use these techniques. But in the next talk, I would discuss the dynamics of a particle and Newton's laws of motion. The next talk will be in parts, so dynamics of a particle, part 1 will be the next talk. I hope that you are liking my lecture. Please click the like button. You may subscribe my YouTube channel by clicking the subscribe button, and you may click the bell icon to get the notification. Thank you for being with me in this series of lecture on fundamentals of